Okay, so here we have a Voltaic cell. This is copper with copper sulfate and zinc with zinc sulfate in the clear container. This is a salt bridge, and what this is essentially doing is we have two half reactions, redox reactions, one oxidation and the other reduction, and they are producing about 1 volt from the current flow. So over at this end, the positive end, the copper end, the copper is reacting with the zinc to produce electrons pretty much through a oxidation reaction. So that is going through reduction reaction at this end, going to the voltmeter, and then it's going to the zinc. The zinc is getting oxidized through a similar process, and that is creating a flow of electrons. These are both 1 molar solutions, and as this reaction proceeds, their concentration of ions will change as the ions from the copper go into solution and the ions from the zinc go on the zinc. And so we have what's called a salt bridge to pretty much balance that out. And this contains a salt which will replenish both ions are going in. Okay, so the reason this cell actually works is because of something called a redox reaction. A redox reaction is essentially any reaction where electrons are transferred. So in this case, we have electrons being transferred between copper and zinc. And you can have all sorts of redox reactions. Anytime there is the flow or changing of electrons, it is a reduction reaction. And a redox reaction, consists of 2 half reactions, which consist of an oxidation reaction and a reduction reaction. In this copper beaker, we have the reaction of copper 2+, which is in solution, forming onto this copper anode, putting 2 electrons through this wire every time that happens. And then on this end, we have the half reaction of zinc going to zinc 2+ and 2 electrons, which means that this end, the copper is going from solution on to the electrode, and over at our anode end, the zinc is going from the electrode into solution. So those are our 2 half reactions. When you put them together, you get essentially the whole reaction, which is zinc plus copper 2+ goes to zinc 2+ and copper. So in this beaker, we have the zinc getting oxidized, which means that it is losing electrons, and over here, we have the copper getting reduced, which means that it is gaining electrons. So currently, our output is about 1 volt. In theory, this cell has a potential of about 1.1 volts. And this is because you can calculate this from both half reactions. So our half reaction for the copper is about plus 0.339 volts, and the cell potential for the zinc reaction is about 762 volts. You can calculate it real easy. You pretty much just combine them, and if you do that, you will get around 1.1 volts. So in the copper reaction, we have ions from solution going onto the copper, and so that means this electrode is going to be gaining mass. On the other end, the zinc electrode is actually going to be losing mass because the zinc is going from the electrode into solution. In and out of solution, we have the salt bridge to balance them, to keep everything at equilibrium and producing voltage.